Hello, my name is Fernando Rodriguez Guzman Jr., and today we'll be going over the Daily Financial Investment Risk Guide as the final project presentation. Overall, the project consisted of several aspects that make up the entirety of the project, from the back end, the actual processing, and the front end visualization. So today we'll be going over the project introduction, the collected data sets, the system architecture overview, the Apache schedule DAGs details, processing and visualization aspects, and lastly, we will conclude with the web interface demonstration, showcasing all the visualization of this project and its subsequent graphs and information. The goal of the Daily Financial Risk Guide was to create an investment risk guide which seeks to explore the feasibility of combining trending world topics, historical stock information, and future stock value predictions to provide a user with the right information for investment decisions leading to investment portfolio growth. Technological automation tools and virtualization techniques were utilized to leverage available datasets throughout daily scheduled data acquisitions. And this collected datasets are processed and visualized to aid an investor in their daily investment decision-making process. Overall, this project aims to understand the value of utilizing daily real-time datasets of financial information for investment decisions leading to the investment portfolio growth of the user. In order to create a reliable risk guide, a total of 10 unique datasets were collected daily for the processing and visualization of relevant financial and global event data. The first 9 datasets include the stock market historical performance of 3 subsections of investment vehicles. These investment vehicles include historically stable mutual funds, historically profitable and stable stocks, and fast-growing stocks. Lastly, daily Twitter data is collected to visualize daily trending world events through the lens of Twitter hashtags. The specific investment vehicles selected were subdivided into 3 major sections: mutual funds, stocks, and fast-growing stocks. The selected mutual funds included Vanguard's 500 Index Fund, VFIAX, Vanguard's Total Stock Market Index Fund, VSNPX, and lastly, the Growth Fund of America's Investment Portfolio, AGTHX. Next, 3 major stocks were also selected due to their stability and long-term growth perspective. The selected stocks included companies like Occidental Petroleum Corporation, OXY, ExxonMobil, XOM, and Vertex Pharmaceuticals, VRTX. Lastly, 3 stocks were selected which had a fast-growing potential for quick gains in the market. These included companies like Enphase Energy Incorporated, ENPH, Shift4, FOUR, and Onsemi, ON. The last major dataset collected was Twitter information datasets. These Twitter datasets were collected on a daily schedule in order to gather information on world events and trending topics. This was done so via the open source Python Twitter API called Tweepy. This allowed for the representation of daily trending events, social mindsets, and any other possible newsworthy item that would be worth tracking for financial investment decision-making and for the overall understanding of financial world events. The system architecture consisted of 4 major sections, which were the cloud computing backend for processing, the Tweepy and Y-Finance APIs for data acquisition, the GitHub repository for storage, and the front-end web interface platform. The foundational computing aspect of this project was performed via Google Cloud's computing platform in collaboration with Apache Airflow toolsets. This Google Cloud computing platform was leveraged in order to create an Ubuntu virtual machine, which hosted Apache Spark and Python scripts in the form of DAGs that allowed for the daily acquisition and processing of information. These DAGs communicated to 2 types of different APIs for dataset acquisitions, including Tweepy for Twitter datasets and Y-Finance for Yahoo financial information for the stocks and mutual funds and other investment vehicles. Subsequently, After processing, all this information was uploaded and stored via GitHub for public access and for web interface acquisitions. This allowed for the front-end web interface designed for this project to gather information stored on GitHub from the Ubuntu VM and DAG process data in order to visualize all the financial information, making one cohesive and unified project for aiding in financial decision-making. The Apache scheduled DAGs and all aspects of the backend dataset acquisition process was automated via the use of Apache Airflow scheduled DAGs. This allowed for the daily acquisition of Yahoo Finance historical stock datasets for all 9 of the investment vehicles selected, and the daily trending Twitter data for processing and visualization. All the data was processed within each DAG, CSV formatted, and stored via GitHub for public access and visualization. Access to the Twitter messages was implemented via the use of the Tweepy Python open source library. This library allowed for the creation of data stream client DAGs, which enabled the connection and acquisition of tweets. The tweets were then tagged to acquire data of interest for the Financial Risk Aid project. The resulting trending tweets were visualized on an HTML CSS web page via a D3 word cloud formatted graphic. For the stock historical datasets, daily historical datasets for each of the 9 investment vehicles were acquired via daily scheduled DAGs, which utilized the Y Finance Python API. Each dataset was processed and stored via a publicly available GitHub project repo. These historical datasets were then visualized via an HTML CSS webpage utilizing a D3 graph for investment decision processing by a user. Lastly, stock price prediction was implemented into the daily financial aid. First, a daily historical dataset was successfully acquired via the Y Finance Python API for each investment vehicle dataset. Next, this was followed by the processing of each dataset and the training of a linear regression model for each investment vehicle. The resulting predictions were visualized on an HTML CSS web page via a D3 interactive graph, allowing for the observation of daily predicted closing costs versus actual historian closing costs. This enables a user to then make estimated and smart decisions for investment portfolio growth. And now we'll begin the web interface demonstration for the financial aids visualization front end. What we have here is the web interface for the daily financial aid. This is one cohesive project and web interface design to have all the available information that you would require for financial decision making in one web interface. And now let's start with the top left corner of the interface. Here you'll see the daily financial aids information of myself, my contact information, as well as the projects for the course information. Next, we'll see the trending words. These words were acquired by the Tweepy interface and are displayed via a D3 cloud interface demonstrating the day's trending information and trending hashtags in order to note any major events or world processes that are happening which may require our attention when we make daily financial investment decisions. Next, we have the beginning of the stock history for AGTHX. As you can see here, this nice D3 infograph actually demonstrates the historical information of this stock. This again can be utilized to make any investment decisions when it comes to AGTX stock history or investment decisions. Next, we have the AGTHX stock predictions. This was done by our linear regression model and is displayed over the past week in order to demonstrate what we observed in the closing cost versus the actual predicted ones. The nice thing about this interface is that it can be selected to display one or the other or both at any given point. This allows for the isolation over time of different predictions versus closing rates in this infograph. And as we scroll down, we see the different stocks that we selected in the same sort of organization, including stock history and stock predictions. All of these which can be self-selected to be visualized or not in this graphic. Next we have 4, its prediction model. And as we keep scrolling down, you will notice that every single one of the interfaces for the stocks are displayed. This one interface then allows an investor to quickly glance through all of its selected stocks and make any investment decisions based on the information available. And this will conclude the demonstration and presentation of the Daily Financial Aid project. I look forward to utilizing the lessons learned from this course both in my academic and professional career. Thank you.